Okay, good morning students. In last class, up to last class, we have seen about first unit. Now should go for second unit. What is the second unit means? Here we have to design some algorithms called fast Fourier transform algorithms. What are the use of fast Fourier transform algorithms, sir? We simply call a fast Fourier transform algorithm as FFT algorithm. Generally, FFT algorithms are used to find out DFT of the given sequence. Sir, we already designed a DFT of the given sequence or making problems on DFT of a given sequence. Okay, we already done DFT of a given sequence by using direct method. In direct method, we have to use the formula of the DFT and find out the DFT of a given sequence. It will depends on its length. If the sequence length is 4, it's okay. 8, it's okay. If that is 32, it is very difficult to find out the DFT of a given sequence. In such case, we will use FFT. How you can do the FFT algorithm? First one, FFT algorithm. We know that DFT can efficiently computed based on divide and conquer method. This approach is applicable when n is not prime number. This approach is very efficient when n is highly composite where r is prime number. In such case, DFT has a size of r. So computation of DFT has a regular pattern. That regular pattern here we have to design. Let's see. Okay, the number r in the radix of FFT algorithm, the number r in the given sequence is called radix of the FFT algorithm. In this section, we will mainly consider on radix 2 algorithms. That means the radix 2 means the radix of the given number must be 2. That means the given sequence length must be divided by 2. If the length is 4, which is divided by 2. If the length is 8, which is divided by 2. If the length is 9, cannot be divided by 2. So it is also performed an approach called divide and conquer approach. That means we have to divide the given sequence into number of subsequences and we have to apply DFT on those subsequences. Then we have to get the final answer. Okay. So here we have to divide the given sequence based on even and odd numbers. That means given x of n, we are having a length of n. Then we have to divide the length into the sequence into two types, two parts of length n by 2 and n by 2. That is f1 having a length n by 2, f2 having a length n by 2. Okay, then that n by 2's length is now half of the amount. We have to divide that n by 2 into n by 4 and n by 4 based on the length of the given sequence. How we can divide, sir? Generally we have 8 for suppose n is equal to 8. How we can divide two types? First based on length 0 to 3, 1 half, 4 to 7, another half. That's a one type. Another type, in the entire sequence take even numbers and odd numbers. X of 0, x of 2, x of 4, x of 6 are the even numbers. 1, 3, 5, 7 are the odd numbers. Like that we can divide the given sequence into two parts. Then we have to apply DFT for each individual part. Then finally we have to cascade all the outputs. Okay, like this. The two sequences can be represented as first one f1 of n is equal to x of 2n, that is for even number. f2 of n is equal to x of 2n plus 1. Consider x of n having a length of capital N. Then f1 of n having a length n by 2, f2 of n having a length n by 2. Now we have divided the sequence into two parts. One is based on even, another one is based on odd. Okay. Next, thus f1 of n and f2 of n are obtained by decimating x of n by factor 2. That means we have divided the sequence x of n by factor 2. Hence, the resultant algorithm is called as decimation in time algorithm. That means here we have divided the sequence by using time. That's why it is called decimation in time algorithm. Here the first what we have to do first. FFT algorithm, we have first step, we have to divide the given sequence into number of parts based on even and odd concept, like this, f1 of n and f2 of n. Next, now endpoint DFT can be expressed in terms of DFTs of decimated sequences. That means this is the general endpoint DFT equation, x of k equal to summation n equal to 0 to n minus 1 x of n wn k. We know that. Now we divide that equation into two parts. One is for odd, another one is for even. For odd, how we can represent? Odd means the total length must be divided into 2. Why? Because in the given sequence we have 4 odd samples and 4 even samples. First one, summation m equal to 0 to n by 2 minus 1, x of 2m, wn 2mk. Next, summation n equal to 0 to n by 2 minus 1, x of 2m plus 1, wn k 2m plus 1. In place of n, here we have written for even 2m, here we have written for odd 2m plus 1. The size of the summation is similar, half of the entire amount, n by 2 minus 1. Next, we know that which is called total factor property, wn square equal to wn by 2, which will obey symmetric property, that is a property. We have to use that in above equation. We get summation m equal to 0 to n to n minus 1 f1 of m wn by 2 km. Here wn power k is taken outside, then we get f2 of m wn by 2 km. Then that entire equation can be written as f1 of k plus wn of k plus f into f2 of k. That means we divide the sequence into two parts, f1 of n and f2 of n. X of n is equal to f1 of n plus f2 of n. If we apply DFT on that, we get x of k equal to f1 of k plus wn power k into f2 of k. Here, here the extra term is this one, wn power k. You already know what is meant by wn power k in the first unit, that is called twiddle factor. wn power k equal to e power minus j 2 pi by k into n, where k equal to 0 to n minus 1. That means we have divided the sequence into two parts and we have applied DFT on those. How we can find out the overall DFT means we have to add those two separate DFTs, make a x of k. That's an equation. Okay, and based on this we have a algorithm for FFT, basic part of the algorithm of FFT, that is called butterfly diagram. From this we can explain butterfly diagram. How, sir? Butterfly diagram means it's just a x symbol like this. Okay, it has two inputs. Here x1, x2 for suppose think. It has two outputs, y1, y2. It's a butterfly structure. Measure. This butterfly is the building block, basic block of the FFT algorithm. That means this butterfly will affect this equation. Okay, that equation will give here. Is it clear? Butterfly diagram majorly depends on this equation, x of k. That means f1 of k plus wn power k f2 of k, where consider x1 is f1, x2 is f2. Then take this type of symbol, okay, in the up arrow, that is called twiddle factor, wn power k. Now the output of the given structure is y1 is equal to x1 plus wn power k x2. What is the one output? Next one, y2 equal to x1 minus wn power k x2. That means a plus jb, one output, a minus jb is the another output. That's the butterfly structure. By using that butterfly we can design FFT algorithm. If we see the algorithm, we can know how many butterflies are there. There are some formulas. Based on that we have to go that much of butterflies. Okay, the major structure is, we have for FFT algorithm we have to divide the given sequence into number of parts by using even and odd concept. We have to apply DFT for each and every part. Then finally all parts of the DFT can be added by using this equation like this. Okay, next again f1 of k is divided into two parts. Okay, let's see where f1 of k and f2 of k are the n by 2 point DFTs. That's why we have to find out n point DFT. First we have to find out n by 2 point DFT, call f1, then f2 for sequences f1 and f2. So what is f1m, what is f2m? Those are the divided sequence what we have divided. Okay, since f1 of k and f2 of k are periodic with a period of n by 2, f1 of k plus n by 2 is equal to f1 of k, f2 of k plus n by 2, f2 of k. Are you seen in DFT properties in first unit? In addition to this, the factor of wn power k plus n by 2 is equal to minus wn power k. That is called a symmetric property, because this total factor obeys periodicity property and symmetric property. The above equation x of k can be represented as like this. X of k is equal to f1 of k plus wn power k f2 of k. X of k plus n by 2 equal to f1 of k minus wn power k f2 of k. Okay, this is the equation. For this we have designed that butterfly diagram. By using that butterfly diagram we can design all FFT algorithms. Let's see. Similarly, if you divide f1 of k into two parts, we get this one. That means where f1 of k is n by 2 point sequence, that is divided into two parts. How? So that's even. f1 of k is even. We have to divide into two parts. How means? Even, in even, even, odd. Two parts. In odd, even, odd, two parts. It is for even, it is for even odd, it is for odd even, it is for odd. That means we have divided the DFT of the given sequence into now four parts. First part is even, second part is even odd, third part is odd even, fourth part is odd. We have to apply DFT for four parts separately. Each part of the DFT is our application of n by 4 point DFT. Okay. For now, we have calculated all n by 4 points of DFT. Then we have to add all those. Okay. Like by using these equations. Then this is the entire DIT FFT algorithm. That means in FFT we have two types. One is DIT decimation in time, another one is decimation in frequency. Here we have divided the given sequence based on time. That's why we get this problem. It is a example for n equal to 8 DIT FFT algorithm. That means we have 8 inputs in the given sequence. First we have to take all those 8 inputs like this. Bit traversal manner, x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, x of 7. 8 inputs means we have 3 stages. Number of stages in the sequence FFT algorithm is n to 2 power n. That is 8, 2 power n. We get 2 cube is equal to 8. That's why we get here 8 input samples. So that means we have 3 stages. That is, it is stage 1, stage 2, stage 3. In each stage, we have n by 2 butterflies. This is a combination of butterflies. This is all stages. You have seen butterfly diagram. Each stage we have n by 2 butterflies. That means we have n equal to 8. That means in each stage we have 4 butterflies. Okay. First we have to connect butterflies like this. Okay. Where each butterfly is separated. What is the input and output distance between butterflies is 2 power n minus 1. Okay. 2 power n minus 1 means 2 cube minus 1, 2 square is equal to 4. By using that formula, we can divide the butterfly structure like this for stage 1. Similarly for stage 2, this is the stage 3 butterfly diagram. And the outputs of the DIT FFT algorithm is in natural manner. X of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. Similarly, we have DIF FFT algorithm like this, where inputs are, it's a reverse of DIT FFT algorithm, where inputs are in natural order, outputs are in bit reversal order. Stage 1 in DIT becomes stage 3, stage 3 in DFT becomes stage 1. Same concept. Number of sequence, now what is the length of the sequence? N is equal to 8. If n is equal to 8, number of stages are 3. Stage 1, stage 2, stage 3. In each stage, n by 2 butterflies are there. That means n is equal to 8 means in each stage we have 4 butterflies. 4, 4, 4. What is the difference? What is the distance between input and output of the butterfly? It's an important. That means it is the input and it is the output. How much distance is there? Based on that distance, we can write the butterflies easily. Okay, that is 2 power n minus n. 2 power n minus n means 2 power n is equal to 8 minus n. Stage index. Stage index means what is the stage value? What is stage 1, stage 1, stage 2, stage 2, stage 3, stage 3, like that. Based on that, we can perform DIF FFT algorithm. Both DIT FFT algorithm and DIF FFT algorithm are used to find out the FFT, that means DFT of the given sequence. What is the use of these FFT algorithms, sir? Which will reduce the complexity of DFT direct method. Okay, that is about DIT and DIF FFT algorithms. Here, direct computation of f1 of k. requires n by 2 whole square complex multiplication. The same applies to f2 of k. There are n by 2 complex multiplications to compute wn power k f2 of k. Hence the computation of x of k requires 2 into n by 2 whole power 2 plus n by 2 complex multiplications. The first step resulting reducing number of multiplications n square to this amount. N square means if I take n equal to 8, what is the n square value? 64 complex multiplications are required to perform DFT in direct method. But in using FFT algorithm, n by n power 2, 64 by 2, 32 plus 4, 36 multiplications are required for FFT algorithm. That means number of complex multiplications are reduced by FFT algorithm while compared to DFT. Okay, the total number of multiplications reduced by a factor of 2 again. This decimation of sequence can be repeated again and again until the resulting sequence reduces the total 2-point sequences. The total number of complex multiplications are required for using FFT algorithm is n by 2 log 2n. And number of complex additions are required n log 2n. These are the two important points. N by 2 log 2n multiplications are required in FFT algorithm. But in direct method we require n square. If I take n equal to 8, 8 square equal to 64. Here n equal to 8, 8 by 2, 4, 8, 4 into 3, 12 multiplications are required. Where we require 64, that's a complex. And number of additions required in direct is n into n minus 1. 8 into 7, 56 requires additions. Here n into log 2n. 8 into 3, 24 additions are required. That means number of complex multiplications and number of complex additions are reduced in FFT algorithm. That's why FFT algorithm is a fast Fourier transform algorithm to find out the DFT of a given sequence. That's why in major cases in problems we are in programs also we have used FFT algorithm to find out the DFT of a given sequence. In MATLAB, FFT algorithm is a inbuilt function. We don't write any program. We will use that FFT algorithm inbuilt function. That's it, to find out the DFT of the given sequence. Okay. This radix 4 FFT algorithm we will see in next class.